Okay. If graphing absolute value equations were easy to you, graphing absolute value inequalities are just as easy. Two things to remember, though, is that it's not always a solid line. Because you have inequalities, you don't have the equal to part sometimes. So sometimes instead of a solid line, you may have a dash or dotted line. Yes, right? Or, and because if it's less than or greater than, you will have it shaded. Here's how you know. If it's greater than, shade above the boundary, okay? Because sometimes your V is going to be down like this. So you just shade above the boundary lines. That V is now a boundary line. You shade above it. If it's less than, you shade below it, right? Other than that, same stuff, same stuff. All right, here we go. Again, for graphing inequalities, the region that represents the solution is the line. It may or may not include that solution. So that boundary line that separates the shaded and unshaded regions could either be dashed if it's less than or greater than, not equal to, or it's solid if it is equal to. So you will be graded on the correct boundary line plus the shading, plus having the vertex and the 2 points in the right spots. Yay! It's so much fun. Yeah. All right. Before we do absolute value, let's relate this to the equation of a line. Yeah? So for example, in the first example, it's a linear equation because there's no absolute value. What's the slope? 1. Nice. Slope is 1. Y-intercept is 4. Cool. Since it's less than, solid or dashed? Dashed. Thank you, Teddy. Dashed. It's not equal to. And then shade above or below? Below. Wow, how many pieces is that? 4. 4. It's 4 things you know. Slope, y-intercept, dash, and where is it shaded? All right. All right. So start at the y-intercept, which is at 4. The slope is 1, so it just goes up 1 over 1, up 1 over 1. Yeah? And then when you make your line, dashed or dotted, whichever you prefer. Okay? And it says shade below, right? Let me use a different color. So pick a point on the line. Let's go with the y-intercept. If it's below, then it's a point that's below the y-intercept is over here. That means any point in this region is a solution to this equation, or inequality. Yeah? That's so easy. That's so easy. Wow. Okay. Example 2. What are the 4 things? Talk to me. Slope is 2. Yep. And then 3. This tells me that the line is solid and shade above. All right. All right. So start at -3. And you go down 2 over 1, down 2 over 1, and so on. Here's what I was talking about going backwards, right? Once you go forwards, if you start running out of like spots, if you do the opposite of before, so instead of down 2 to the right one, go up 2 to the left one, and you'll find something on this side too. Just go opposite, that direction. Solid line. Sorry, my line is not pretty. Yay. All right, if you're shading above, pick a point on the line, and a point above it is where everything's going to be. So everything in that thing is going to be there. Sweet. All right. All right. Absolute values then. Am I going too fast? It's good? Okay. There we go. There we go. All right. 5 things I need. Vertex. Here we go. Number 1, vertex. Woo! Sweet. So before and after -4 would be -5 and -3. Using your handy dandy calculator. Or plugging it in, I don't know. Yeah. Absolutely. Yes, here's why. Because we're finding the boundary line. So you found the boundary line the same way you find like the regular line. It's the shading part and the solid and dash part. That's like, yeah. What do we got? Zeros, right. And here's how you know you did it right. These two should line up because they're the same distance away from -4, so it should be 0 and 0. Okay? So 1, 2, 3. Two more things. What else? It is dashed. Thank you, sir. And shade above. Sweet. Okay. So -4, -1 is -4, -1 over here. -5, 0, -3, 0. Mr. Ian, or was it Jackson? Here we go. There you go. Is it Jackson? Yeah. It says it's dashed, right? Remember, that's a boundary line. So anywhere on that line, just pick a point. Anywhere on that line and shade above that point. So, like if you take the vertex, any point above this line, this looks terrible. Oh, it's a flower. All right, there you go. Looks like that. Yeah, yeah. Which, I mean, I know that you're doing this like as kind of like repetitively, but basically any point in this region is a solution to that inequality. So like the point -4, 0, right? -4, 0. If you plug in -4, 0 into that equation, it will be a true statement. Y will be greater than that. Yay? Yay. All right. Vertex. All together? Yes, you remember to poop. 1, 3. There you go. Pull out opposites from parentheses. Right. Yeah. All right. So before and after 1 are 0 and 2. Plug and chug. What do we got? And 2 and 1. Right? Because it should be the same thing. All right. 1, 2, 3. Two more things. Solid. And below or down. Yeah. Yep. So 1, 3, 0, 1, and then 2, 1. Which, by the way, Mr. Collin over here figured out that A is the slope, actually. So if you go from the vertex to find the positive one, you go down 2 over 1, right? Just go down 2 over 1. Let's get the other one. You just go down 2 over 1, too. That's good. All right. Nice job, Collin. Yeah. Yeah. Okay. Shade below the boundary line. So start at the vertex. That's the easiest point. Any spot below it. Yay, it's a party hat. Yeah. Party hat. Is it good? Okay. Here ends the lesson for absolute values. Tomorrow's the review, and then Wednesday is the test. Any questions, comments, concerns? We good? Let's see how good you are. Yes, Ian. What's up? You know, Wednesday, it sounds like a really good test day. I feel like, yeah.